Hello friends, it's MoNaCo here with our first video for homework in our second unit. We're starting atomic theory this week. And by the end of this video, you're going to understand that the modern model of the atom as we know it is the work of many, many scientists over the past about 2,500 years. So the idea of the atom is not new, and it's been evolving for a very long time. So you're going to get to know about all those scientists and their contributions in this first homework video. So our lead-in is, what is a model in chemistry? Well, we all know that the atom is the smallest unit of matter, but how did we develop that idea that you can represent it as a sphere or as a symbol with these the electrons circling around it that everybody recognizes from like nuclear power plants and things? And what a model is it's really just a representation. It's a visual, it's a graphic that tells you a story about something that can't necessarily be seen. So these models that we're going to talk about have been evolving, and each little new scientific discovery adds to the model as it grows, and the idea of science is that it's a progression. So everybody knows that the basic building block of matter is the atom, and you can't break it down with chemical reactions. You can do that with radioactive reactions, but that is the last unit of the year. The first person to think of this atom, or the concept, was this guy called Democritus. He was an ancient Greek philosopher, 450 BC, so 450 years before Christ. He coined the term atomos to describe the smallest particle of matter. It was about, 2,300 years later that John Dalton in 1803 came up with the modern atomic theory. So we give him the credit for founding it. And he had four postulates, which are, it's a synonym for ideas, is that everything is made of indivisible particles called atoms. So everything's made out of atoms. And this is another important part that is also true, that all atoms are identical in properties. Okay, that's not exactly true with respect to mass, but in 1803 it certainly was, and it still holds some truth today. Also, the third postulate also holds very true today, is that compounds are formed by two or more different atoms getting together. And then this fourth postulate actually covers the entire topic in college called thermodynamics, is that atoms can't be created or destroyed, but they can only be moved and browned into each other in different chemical reactions. So these four postulates are still very much looked to as being truth. His model was the cannonball theory. It was just like a spherical, uniform, dense type particle, like a cannonball or a marble, and it didn't have any smaller parts inside of it. Okay. So the next person to think about the atom and study it and publish results was about 95 years later. So not much happened for a long time, but technology grew, and this guy named J.J. Thomson used what we call a cathode ray tube. You might have seen one of these in a big old tube television. He used a very basic model of that to discover that this cathode ray can be deflected towards a positive electrode and away from a negative electrode. And he said that, geez, these atoms that we're shooting through this cathode ray tube, they're getting bent. What could that mean? And he attributed that bending of the beam to a new particle inside the atom called the electron. He said it was very small, which is very true. And based upon the direction that it bent inside this cathode ray tube, he decided that it was negatively charged. Okay? He was the first person to ascribe a charge to the electron, which was a big deal, because nobody knew electrons even existed up until now. His model was called the plum pudding model, or the plum pudding theory. There's a picture of it to the right here, and he said that the positive plum pudding, in this picture, I like to think of it more like a cookie, a chocolate chip cookie. The positive part would be the cookie dough, okay? And the negative part would be like the electrons or the chocolate chips stuck in there. He was British, so that's why he called it plum pudding. I guess that's a delicacy over there. I would have named it the cookie model or raisin bread model. But that was in 1897. About 10 years later, more scientists, this guy named Ernst Rutherford, I think he was Scottish, was also studying the atom. He conducted the most famous experiment that you must know about. It's called the gold foil experiment. And what he did is he bombarded a very thin piece of golden foil, almost an atom thick, with a positively charged stream of alpha particles. He knew from radioactivity studies that these particles were positively charged, and he shot them at this little thin piece of foil. And he expected that, these particles would be like bullets going through tissue paper, like zip, 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 all go straight through the foil, and, he wasn't expecting much. But what happened was that, as you can see in the picture above, the red line is the alpha particle beam, and as it hit the gold foil, some of them, oddly enough, bounced back, Most of them went straight through like he predicted, but every now and then you'd get one that bent a little bit or even more bounced straight back. So his new conclusion, he said, well, there's something else in this atom, and it must be causing those positively charged particles to bounce around or bend. So he came up with this nuclear theory model. He said that the atom is mostly empty space because most of his particles went straight through, like he predicted. But at the center, there's something positive and dense that can occasionally cause one of his alpha particles to bounce around or change course. And he called that the nucleus. So he's the first person to coin the term nucleus. And he also learned that the atom is, in fact, mostly empty space. This is still true to this day. Okay. Now, sometime later, as you can see, these studies are becoming more and more closely packed together. So only about 4 years after Ernst Rutherford did his famous gold foil experiment, another man named Niels Bohr, who was a theoretical physicist, not necessarily a chemist, he was thinking about the behavior of light and electrons, and he created what we know now as called the Bohr model or planetary model. And this is what you might vision in your head when you think of an atom. We got a core with all these rings of electrons around it zipping around, okay? That's the most pop culture model of the atom that you would be familiar with. He said that the electrons are traveling around the nucleus in well-defined paths called orbits, okay? Just like atoms or planets go around the sun, electrons are going around the core of the atom in orbits. He said that electrons in different orbits have different amount of energy. And if you think of like the orbitals as a staircase, the ones that are up towards the top, the outer levels, have more energy when they are circling the atom. He also said that those electrons can move within the orbits. They can climb the stairs, if you will. And by climbing the stairs, they're gaining energy, and it caused them to get jumped up to the higher next step. Okay, and then he coined the term that was called the excited state because they've gotten excited, they've juiced up, they've got a lot of energy. And then when the excited electrons lose their energy as they climb back down the stairs, it causes them to fall back down to a lower energy level in what he called the ground state. This constant back and forth of the electrons gives us what we know today as light. Okay, any colored tube lights over your head are using this concept of excitation and emission to create the light that illuminates our classroom. So very, very important concept. We're going to make models of these in a later video. The last model, the most modern model, is what we call the wave mechanical or the cloud model. Okay, and this was developed through World War II and the contributions of many, many, many scientists. So there's no one superstar to give credit to here. And as you can see here in the top left corner, it's not an atom's nucleus with defined paths around it, but it's more like clouds of where the electrons might be. And we call those orbitals still in tribute to Bohr and what he discovered. But instead of it's a fixed path, it's where you're most likely going to find an electron. Not necessarily circular. These orbitals actually have some funky shapes, but that's in an AP chemistry course. Developed after the famous discovery that particles, like the electron, both behave like waves and particles. So it's an electron. You can think of it like a little marble, but it also behaves like waves and ripples in a pond. So there's this weird duality nature of the electron that helped coin this model. Many scientists like Schrödinger, de Broglie, Planck have contributed to this theory. These are also the scientists that contributed to the Manhattan Project and the creation of the nuclear bomb that ended World War II. All right, so at this point, you should understand that there's some practice that you've got to do here. I'm not going to go through these for you right now. You should take the information that I just talked about and you wrote down in your notes to complete these questions. Okay, and to recap it all together, you should now understand that the modern model of the atom, the wave mechanical model, is old and it has evolved over a long period of time. And some of the scientists that I mentioned and we took notes about are important. The most important being Ernst Rutherford and his gold foil experiment. So thanks for watching. See you later.